Normandy, France, June 12, 1944. The thunderous roar of diesel engines echoes across the French countryside as columns of American armor roll inland from the beaches. Dust clouds rise behind the advancing formations, and for the first time since the invasion began, German forces are retreating in organized panic. At the head of these columns, medium tanks with sloped armor and 75mm guns push forward relentlessly, their commanders standing tall in their turrets, scanning the horizon for targets. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. But what the German defenders cannot see, what their intelligence reports have failed to capture, is the true nature of what approaches them. These are not merely tanks. They are the product of a classified directive issued 18 months earlier, buried so deep in Allied command structure that even many American generals remain unaware of its existence. Operation Steel Thunder, as it was codenamed, would transform the humble Sherman tank from a stopgap solution into the most feared weapon system on the Western Front. The story begins not with steel and fire, but with paper and paranoia. In the winter of 1942, deep within a nondescript building in Washington, D.C., Colonel Harrison Wright received a folder marked with classifications that few officers in the entire U.S. Army possessed clearance to read. The documents inside would change the course of armored warfare forever, but their origins lay in a growing crisis that threatened to derail the entire Allied war effort. American tank production in 1942 was impressive by any measure. Factories across the United States were churning out thousands of Sherman tanks, and their numbers would eventually dwarf anything the Germans could produce. But numbers meant little if the vehicles themselves were inadequate for the challenges they would face. Intelligence reports from North Africa painted a disturbing picture. German Panzer IV tanks and the newer Tiger I tanks just entering service were systematically destroying American armor in head-to-head engagements. The problem was not courage or training. American tank crews fought with determination that impressed even their enemies. The issue was fundamental design philosophy. American tanks had been built for mobility and reliability, optimized for the industrial production methods that were America's greatest strength. But they had not been designed to face the heavily armored, high-velocity guns that German engineers had perfected. Colonel Wright spread the classified reports across his desk and studied them with growing alarm. Tank battles in Tunisia showed kill ratios that were simply unsustainable. For every German tank destroyed, the Americans were losing 3 or 4 Shermans. At this rate, numerical superiority would mean nothing. The Wehrmacht would simply grind down Allied armored forces through superior technology and tactical doctrine. The solution, when it came, emerged from an unlikely source. Captain Elena Vasquez, a mechanical engineer who had been recruited directly from General Motors, had been analyzing captured German equipment at the Aberdeen Proving Ground in Maryland. Her background was unusual for military service. She had spent the previous decade designing automotive transmissions, working with metallurgy and precision manufacturing techniques that most military officers did not fully understand. Vasquez had been examining the armor composition of a captured Panzer IV when she noticed something that previous analysts had missed. The German armor was not simply thicker than American equivalents. It was fundamentally different in its internal structure. While American armor was designed to stop projectiles through pure thickness, German armor used complex layering techniques that deflected incoming rounds while maintaining relatively light weight. Her report to Colonel Wright was technical and dense, filled with metallurgical terminology that required translation for military audiences. But its implications were revolutionary. American industry, with its advanced steel production capabilities and precision manufacturing, could potentially produce armor that was not only equivalent to German designs, but superior. The challenge was not technological capability, but time and secrecy. The Germans had spent years developing their armor technology, testing different compositions and manufacturing techniques through actual combat experience. American forces preparing for the invasion of Europe did not have years. They had months, perhaps less, before the opening of the second front would require every available tank to face battle-tested German defenses. Colonel Wright brought Vasquez's findings to General Leslie McNair, who commanded Army ground forces and oversaw all tank development programs. McNair was known for his analytical approach to military problems and his willingness to challenge conventional wisdom. He had already been questioning whether American tank doctrine adequately reflected the realities of modern warfare. The meeting took place in a secure conference room at the Pentagon, with only a handful of officers present. General McNair listened as Vasquez explained her findings, occasionally asking technical questions that revealed his own engineering background. When she finished, the room fell silent for several long moments. Finally, McNair spoke. The implications of what Vasquez was suggesting went far beyond simple improvements to existing tank designs. She was proposing a complete reconceptualization of how American armor would fight. Instead of relying on numerical superiority and tactical mobility, American tanks could potentially match German vehicles in direct combat, gun for gun, and armor for armor. But the proposal also raised enormous logistical and security challenges. Implementing these improvements would require retooling production lines, retraining manufacturing workers, and developing entirely new supply chains for specialized materials. More critically, it would need to be done in absolute secrecy. If German intelligence learned that American tank capabilities were about to dramatically improve, they would undoubtedly accelerate their own development programs. General McNair authorized what would become known as Operation Steel Thunder that same afternoon. The directive was classified at the highest levels, with access restricted to fewer than 50 individuals across the entire Allied command structure. Even General Omar Bradley, who would eventually command the American forces that would benefit from the program, was not initially briefed on its existence. The operation required the construction of entirely new production facilities disguised as conventional manufacturing plants but equipped with specialized equipment for advanced metallurgy. 3 locations were selected: a converted automobile plant in Detroit, a steel mill in Pittsburgh that was expanded under cover of increased conventional production, and a completely new facility built in rural Kentucky under the guise of an agricultural equipment factory. Dr. Richard Chen, a materials scientist who had emigrated from China before the war, was recruited to head the technical development team. Chen had spent years studying advanced steel production techniques, and his expertise in both American industrial methods and theoretical metallurgy made him uniquely qualified for the challenge ahead. Working 18-hour days in facilities that officially did not exist, Chen's team began developing what they called enhanced armor composition. The new armor used multiple layers of different steel alloys, each with specific properties that contributed to overall defensive capability. The outer layer was designed to disrupt incoming projectiles, while inner layers absorbed and dissipated the remaining energy. But armor was only part of the challenge. Captain Vasquez had also identified weaknesses in American tank guns that needed to be addressed. The standard 75mm gun mounted on... Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
Sherman tanks was adequate against existing German armor, but intelligence suggested that new German designs would render it obsolete. The solution required developing new ammunition types and improving gun performance without making obvious external changes that would alert German observers. The ammunition development program was assigned to Lieutenant Colonel James Harrison, an artillery officer who had spent years working with experimental projectiles. Harrison's team worked in parallel with the Armor Development Group, creating new shell designs that could penetrate the improved German armor while maintaining compatibility with existing gun systems. The new ammunition used tungsten cores, a material that was extremely expensive and difficult to obtain in wartime conditions. Acquiring sufficient quantities required secret negotiations with neutral countries and careful management of domestic tungsten production. Every shell represented a significant investment of rare materials and specialized manufacturing time. By the spring of 1943, prototype tanks incorporating the new armor and ammunition were ready for testing. The trials took place at a remote facility in Nevada, far from any potential observation by German agents. The test results exceeded even the most optimistic projections. Tanks equipped with enhanced armor composition could withstand direct hits from German 88mm guns, the weapons that had previously been death sentences for American armor crews. More importantly, the new tanks could effectively engage German armor at ranges that had previously favored the enemy. In simulated combat scenarios using captured German vehicles, the enhanced Shermans achieved kill ratios that completely reversed the equation that had troubled American commanders in North Africa. But success in testing was only the beginning of an even more complex challenge. The enhanced tanks needed to be produced in quantities sufficient to equip entire armored divisions, and they needed to reach combat units without revealing their improved capabilities to German intelligence. The deception program that accompanied Steel Thunder was almost as sophisticated as the technical development itself. Externally, the enhanced Sherman tanks appeared identical to standard production models. The improved armor was installed in ways that did not change the vehicle's silhouette or obvious characteristics. Even American tank crews were not initially told about the upgrades, receiving their vehicles through normal supply channels with no indication that they represented revolutionary improvements in capability. The ammunition program required even more elaborate deception. The new tungsten core shells were mixed with conventional ammunition in ratios that would prevent German forces from recognizing their improved performance until it was too late. Tank crews were instructed to use the enhanced ammunition sparingly, reserving it for the most critical engagements. Training programs were modified to prepare crews for the improved performance of their vehicles without explicitly revealing the nature of the upgrades. Tank commanders were taught new engagement tactics that took advantage of their improved armor protection and gun performance, but these changes were presented as refinements of existing doctrine rather than responses to enhanced equipment. German agents in neutral countries reported unusual purchasing patterns for specialized materials. However, German analysts interpreted these signs as evidence of increased production volume rather than improved capability. Their assessment was that American industry was simply building more tanks of existing designs, an interpretation that fit their understanding of American industrial doctrine and did not suggest any immediate threat to German tactical superiority. This misinterpretation was partly the result of German assumptions about American technological capability. German military leaders had developed a somewhat dismissive attitude toward American engineering, viewing it as focused on mass production rather than technical sophistication. This prejudice prevented them from recognizing that American industry could potentially match or exceed German innovation when properly motivated and directed. The first enhanced Sherman tanks began reaching combat units in late 1943, but their improved capabilities remained hidden during the Italian campaign. Tank crews were instructed to engage German armor using conventional tactics, avoiding situations that would reveal their vehicles' enhanced performance. This restraint required considerable discipline, as many crews found themselves in situations where their improved capabilities could have saved lives. Lieutenant Michael Torres, commanding a tank platoon in the 1st Armored Division, later described the frustration of knowing his tank could destroy German Panzer IVs at ranges where conventional Shermans would be outgunned, but being ordered to maintain the deception. "We watched good men die because we couldn't reveal what our tanks could really do," he remembered, "but we understood that the bigger picture required patience." The deception was maintained even within American forces through compartmentalization. Tank crews knew their vehicles performed better than expected, but were told this was due to improved training and tactics rather than equipment upgrades. Maintenance personnel were aware of differences in armor composition, but were informed that these represented minor manufacturing improvements rather than fundamental design changes. As preparations for D-Day intensified, the scope of Steel Thunder expanded dramatically. The number of enhanced tanks in frontline units increased from dozens to hundreds, then to thousands. By June 1944, nearly half of all Sherman tanks scheduled to participate in the Normandy invasion had been equipped with enhanced armor composition and new ammunition.
The logistics of maintaining this deception while preparing for the largest amphibious invasion in history were staggering. Enhanced tanks had to be shipped to Britain along with conventional models, stored in facilities that could maintain security, and distributed to combat units without revealing their special status. The complexity of tracking which tanks had which capabilities required an entirely separate administrative system. General Eisenhower was briefed on Steel Thunder only weeks before D-Day, when the operational requirements of the invasion made his knowledge essential. His initial reaction was amazement that such a massive program had been conducted without his awareness, followed by concern about the operational implications of revealing enhanced capabilities during the invasion. The decision was made to continue the deception through the initial stages of the Normandy campaign. Enhanced tanks would fight alongside conventional Shermans, using their improved capabilities only when absolutely necessary for mission success or crew survival. The goal was to allow German forces to continue believing they maintained technological superiority until American forces were firmly established on the continent. The true test would come when American armor encountered the best German tanks in sustained combat. Intelligence reports suggested that elite German armored units equipped with Tiger I and Panther tanks were being moved to Normandy to oppose the invasion. Vehicles represented the pinnacle of German tank technology, and their presence would provide the ultimate validation of Steel Thunder's effectiveness. Captain Elena Vasquez, now promoted to major and assigned to observe the program's combat performance, arrived in Normandy 3 days after D-Day. Her mission was to assess how enhanced tanks performed against German armor and to identify any modifications needed for future production. She carried with her authorization to reveal the truth about Steel Thunder to selected unit commanders if battlefield conditions required it. The first major tank engagement involving enhanced Shermans occurred near the village of Comont on June 15, 1944. Elements of the 2nd Armored Division encountered German forces, including several Panther tanks that had been positioned to block American advances inland from the beaches. The engagement would prove to be the first real test of 3 years of secret development and preparation. Staff Sergeant Robert Murphy, commanding an enhanced Sherman, later described his shock when his first shot penetrated the front armor of a Panther tank at a range where conventional wisdom said it was impossible. "I thought I was seeing things," he recalled. "We'd been told those cats were invincible from the front, but my gunner put a round right through the turret face like it was paper." The German response was immediate confusion, followed by tactical adaptation. Panzer crews who had grown accustomed to engaging American tanks with confidence suddenly found themselves facing return fire that could penetrate their armor at ranges they had considered safe. Radio intercepts revealed German commanders requesting immediate reinforcement and reporting that American tanks appeared to have significantly improved capabilities. But the full extent of Steel Thunder remained hidden because enhanced tanks continued to operate alongside conventional Shermans. German observers could not determine which American tanks possessed improved capabilities and which remained vulnerable to existing weapons. This uncertainty forced German forces to treat all American armor as potentially dangerous, fundamentally altering their tactical approach. The psychological impact on German tank crews was profound. The confidence that had sustained them through years of combat against numerically superior but technically inferior opponents began to erode. Tank commanders who had previously engaged American armor with aggressive tactics became cautious, seeking to avoid direct confrontation whenever possible. Major Vasquez documented these changes in detailed reports sent back to Washington through secure channels. Her analysis suggested that Steel Thunder was achieving effects far beyond the technical specifications of the enhanced tanks themselves. The program was undermining German morale and forcing tactical changes that reduced their overall effectiveness. The success at Comont led to gradual expansion of enhanced tank employment. Unit commanders who had been briefed on their vehicles' true capabilities began using them more aggressively, though still within constraints designed to maintain operational security. The results were dramatic improvements in American armor performance that German intelligence struggled to explain. By late June 1944, German tank units in Normandy were reporting encounter rates with American armor that completely contradicted their previous experience. Instead of achieving favorable kill ratios through superior technology, they found themselves facing opponents that could match their firepower and armor protection while maintaining numerical superiority. Colonel Klaus Brenner, commanding a German panzer regiment facing American forces near St. Vith, sent increasingly desperate reports to his superiors describing the changing nature of American armor. "The enemy tanks appear to have been substantially upgraded," he wrote. "Previous tactical doctrines based on technological superiority no longer apply. Request immediate technical assessment and reinforcement." German technical intelligence teams were dispatched to examine destroyed American tanks, but their analysis was complicated by the fact that not all Sherman tanks possessed enhanced capabilities. The mixture of conventional and upgraded vehicles in American units made it difficult to determine exactly what improvements had been implemented and how widespread they were. The deception was further maintained through careful battlefield recovery procedures. Enhanced tanks that were damaged or destroyed were given priority for recovery and repair, preventing German forces from conducting detailed technical analysis. When recovery was impossible, thermite charges were used to destroy specific components that might reveal the nature of the armor improvements. As American forces broke out of Normandy and began their advance across France, the employment of enhanced tanks became increasingly aggressive. The operational requirements of rapid advance and sustained combat made it impossible to maintain the same level of deception that had characterized the early stages of the campaign. The Battle of Arcourt in September 1944 became the first engagement where enhanced Sherman tanks were employed without significant restraint. The 4th Armored Division, spearheading General Patton's advance, encountered elements of the 5th Panzer Army in a series of running battles that would demonstrate the full potential of Steel Thunder. Lieutenant Colonel Richard Hayes, commanding a tank battalion equipped entirely with enhanced Shermans, later described the engagement as a revelation. "For the first time, we could fight German armor on equal terms," he said. "Our boys knew they had something special and they used it. The confidence change was immediate and dramatic." The results at Arcourt were devastating for German forces. In 3 days of combat, American armor destroyed over 100 German tanks while losing fewer than 20 of their own. The kill ratios completely reversed the pattern that had characterized earlier battles, shocking German commanders who had come to rely on technological superiority to offset numerical disadvantages. German after-action reports from Arcourt revealed growing awareness that American tank capabilities had fundamentally changed. Technical intelligence officers noted that American tanks were achieving penetrations against German armor that should have been impossible with standard 75mm guns and conventional armor protection. The truth about Steel Thunder began to emerge through interrogation of captured German officers who reported facing American tanks with dramatically improved performance. But by this point, the strategic initiative had shifted decisively to Allied forces, and German industrial capacity was too strained to respond effectively, even with accurate intelligence. The final phase of Steel Thunder's deception came during the Battle of the Bulge in December 1944. German forces launched their last major offensive in the West, partly based on the assumption that they could still achieve favorable exchange ratios against American armor. The reality they encountered was far different from their expectations. Enhanced Sherman tanks played crucial roles in stemming the German advance, particularly around Bastogne and in the northern shoulder of the Bulge. Their ability to engage German armor effectively at all ranges prevented the breakthrough that German planners had counted on to reach their objectives. Sergeant First Class Anthony Romano, commanding an enhanced Sherman during the defense of Bastogne, later described the psychological impact on German crews. "You could see them hesitate," he said. "They'd been told they could roll right through us like they had before. When they realized our tanks could hurt them just as badly as theirs could hurt us, their whole attitude changed." Capabilities on the Western Front. While German forces continued to resist fiercely, their ability to conduct large-scale armored operations was broken by the combination of material losses and the realization that their technological advantages had been neutralized. The success of Steel Thunder extended beyond its immediate tactical impact. The program demonstrated American industry's ability to compete with German technology when properly focused and motivated. It proved that mass production methods could be combined with advanced engineering to produce weapons systems that matched or exceeded the performance of smaller-scale, artisanal German production. More importantly, Steel Thunder illustrated the strategic value of operational security and deception. By concealing their improved capabilities until German forces were committed to battle, American planners ensured maximum psychological and tactical impact. The program turned what should have been a technological arms race into a strategic surprise that German forces could not effectively counter. The enhanced Sherman tanks produced under Steel Thunder would continue fighting through the end of the European War, spearheading the advance into Germany itself. Their crews, initially unaware of their vehicle's special capabilities, had grown to understand and appreciate the advantages they possessed. The confidence generated by reliable equipment that could match enemy capabilities became a crucial factor in American tactical superiority. As Allied forces crossed the Rhine and advanced toward Berlin, enhanced Sherman tanks led the way, their crews no longer constrained by operational security requirements. The full capabilities of Steel Thunder were revealed in the final battles of the European War, as American armor demonstrated conclusively that the era of German technological dominance had ended. The legacy of Steel Thunder would extend far beyond the immediate context of World War II. The program established precedents for classified military development programs that would characterize the Cold War era. It demonstrated the strategic value of maintaining technological surprises and the importance of coordinated deception in modern warfare. For the tank crews who fought in enhanced Shermans, the program represented something more personal. They had been given tools that allowed them to face their enemies on equal terms, equipment that reflected their nation's industrial capability and commitment to their survival. The confidence generated by reliable, effective weapons became a crucial component of American military effectiveness. The story of Steel Thunder remained classified for decades after the war, known only to the participants and the officials who had authorized its creation. The enhanced Sherman tanks were gradually withdrawn from service and replaced by newer designs, their special capabilities becoming footnotes in classified technical histories. But the impact of the program continued to resonate through American military doctrine and industrial policy. The success of Steel Thunder established the template for future crash development programs, demonstrating that American industry could respond rapidly to technological challenges when properly motivated and organized. The men and women who created Steel Thunder had taken a desperate situation and transformed it into strategic advantage through innovation, security, and determination. Their work remained hidden for nearly 50 years, but its effects shaped the outcome of the most important conflict of the 20th century. The enhanced Sherman tanks that rolled through Normandy and across Europe carried with them more than improved armor and ammunition. They represented the culmination of American industrial might applied to military necessity, the product of countless hours of secret development and testing, and the embodiment of a nation's commitment to victory through technological superiority. Their crews, fighting in vehicles whose true capabilities they only gradually understood, became a crucial component of American military effectiveness.
Understood, had been given the tools to match their enemies on equal terms. The confidence generated by reliable, effective equipment became a crucial factor in the Allied victory, demonstrating that technological innovation could be as decisive as numerical superiority or strategic planning. The success of Steel Thunder proved that American industry, when properly focused and motivated, could match or exceed any technological challenge presented by enemy forces. It established precedents for classified development programs that would characterize American military policy for generations to come, setting the stage for the technological competitions that would define the Cold War era. As the enhanced Sherman tanks crossed into Germany itself, their secret no longer mattered. The strategic surprise had been achieved, German resistance was crumbling, and the technological advantages that had sustained Wehrmacht confidence for years had been definitively countered. The humble Sherman tank, transformed by American ingenuity and determination, had become exactly what its creators intended. Germany's greatest fear made manifest in steel and fire. The morning mist hung heavy over the fields near Caumont as Staff Sergeant Robert Murphy adjusted his periscope and scanned the tree line ahead. His Sherman tank, designation Iron Horse, sat motionless among the hedgerows that had turned Normandy into a deadly maze for advancing Allied forces. Murphy had no idea that his vehicle represented the culmination of 3 years of secret development, or that the next few hours would validate the most ambitious deception operation in military history. At 0847 hours, movement flickered to the morning shadows. The distinctive angular silhouette of a German Panther tank emerged from concealment, its long-barreled 75mm gun traversing slowly as it searched for targets. Murphy's gunner, Corporal David Chen, had already identified the threat and was adjusting his sight picture. In conventional circumstances, this engagement would have been suicide for the American crew. The Panther's frontal armor was designed to deflect anything the standard Sherman could throw at it. Murphy keyed his radio to alert other tanks in his platoon, then gave the command to fire. The 75mm gun roared, and the tungsten core shell struck the Panther's turret face with devastating effect. Instead of deflecting harmlessly, the projectile punched through the German armor as if it were ordinary steel. The Panther lurched to a stop, smoke beginning to pour from its hatches. Corporal Chen stared through his sight in disbelief. "Sergeant, did we just kill a cat from the front?" The question hung in the air as Murphy tried to process what had happened. His training had emphasized that Panthers were invulnerable from the front at anything beyond point-blank range. Yet his tank had achieved what should have been impossible. The German response was swift but confused. A second Panther, positioned to provide overwatch for the first, opened fire at Murphy's Sherman from a range of 800 meters. The high-velocity shell struck the American tank's turret face, a hit that would normally have been catastrophic.
Be a standard American medium tank. The psychological impact on German forces was immediate and profound. Radio intercepts revealed German tank commanders requesting clarification about American capabilities, reporting encounters that contradicted everything they had been taught about Allied armor. The confidence that had sustained Wehrmacht tank crews through years of combat began to erode, as they realized their technological advantages were disappearing. Obergefreiter Hans Weber, commanding a Panzer IV in the same engagement, later described his shock at witnessing the Panther's destruction. "We had been told that American tanks were inferior, that our armor could stop anything they could fire. Seeing that monster Panther burning from a frontal hit changed everything. If the Americans could do that to our best tanks, what chance did we have in our Mark IV?" The tactical implications became apparent within hours. German armored units that had previously engaged American tanks with aggressive frontal attacks began adopting more cautious approaches, seeking to avoid direct confrontation whenever possible. This defensive mindset fundamentally altered the dynamics of armored combat in Normandy, giving American forces psychological advantages that complemented their numerical superiority. But the full scope of Steel Thunder remained hidden even from American forces. Enhanced tanks operated alongside conventional Shermans in the same units, creating a complex battlefield environment where some American tanks possessed dramatically improved capabilities, while others remained vulnerable to German weapons. This mixture prevented German intelligence from determining the extent of American improvements. Captain William Rodriguez, commanding a tank company that included both enhanced and conventional Shermans, described the challenges of managing this mixed force structure. "Half my tanks could take on anything the Germans had, while the other half needed to avoid direct engagement with heavy armor. The tactical complexity was enormous, but the Germans never knew which was which." German technical intelligence teams were dispatched to examine destroyed American tanks, but their analysis was hampered by careful Allied deception measures. Enhanced tanks that were damaged or destroyed received priority for recovery, preventing detailed German examination. When recovery was impossible, thermite charges destroyed specific components that might reveal the nature of the armor improvements. The deception extended to American logistics networks as well. Enhanced ammunition was distributed through normal supply channels, mixed with conventional rounds in ratios that prevented German forces from recognizing improved American gun performance. Tank crews were instructed to use the tungsten core shells sparingly, reserving them for critical engagements where conventional ammunition would be inadequate. Lieutenant Michael Torres, whose enhanced Sherman had survived 3 direct hits from a German 88mm gun during the fighting around St. Vith, remained unaware of his tank's special status for weeks after the engagement. "I thought I was the luckiest tanker in the European theater," he later recalled. "My tank seemed to bounce shells that should have killed us. It wasn't until much later that I learned why." The gradual revelation of enhanced capabilities followed a carefully orchestrated timeline. As American forces consolidated their positions in Normandy and prepared for the breakout operation, commanders received increasingly detailed briefings about their tanks' true potential. The timing was crucial, as operational security required maintaining the deception until German forces were too committed to adapt effectively. General Omar Bradley, commanding American ground forces in Normandy, was fully briefed on Steel Thunder only after the successful establishment of the beachhead. His reaction combined amazement at the program's scope with concern about its operational consequences.
Implications. "You're telling me that half my armor has been fighting with one hand tied behind its back?" he asked Major Vasquez during her briefing at the 12th Army Group headquarters. The answer was more complex than Bradley realized. Enhanced Sherman tanks had been designed not just for superior combat performance, but for psychological impact on German forces. The revelation of American capabilities was timed to coincide with critical phases of the campaign, maximizing disruption to German tactical planning and morale. The breakout from Normandy provided the first opportunity to employ enhanced tanks without significant restraint. Operation Cobra, launched on July 25, 1944, saw American armored divisions spearheading the advance with tanks whose capabilities had been concealed for nearly a year. The results were spectacular, as German forces found themselves unable to establish effective defensive lines against armor they could no longer reliably defeat. Colonel Klaus Brenner, commanding the German 116th Panzer Division, sent increasingly desperate reports to his superiors as American armor rolled through positions that should have been impregnable. "Enemy tank capabilities appeared to have been substantially upgraded," he radioed to Army Group B headquarters. "Previous defensive doctrines based on technological superiority no longer apply." The German High Command's response revealed their confusion about American improvements. OKW intelligence assessments suggested that American industry had simply increased production of existing designs, failing to recognize that qualitative improvements accompanied the quantitative increases. This misinterpretation reflected long-held German assumptions about American technological capabilities. German engineering teams attempted to respond to the changing battlefield conditions, but their efforts were hampered by resource constraints and industrial bottlenecks. The complex manufacturing processes required for advanced armor production could not be rapidly scaled up, particularly as Allied bombing campaigns targeted German industrial infrastructure. Meanwhile, American production of enhanced Sherman tanks accelerated as the program's success became apparent. The 3 secret facilities constructed for Steel Thunder operated around the clock, producing tanks that were externally identical to standard models, but possessed dramatically superior combat capabilities. Quality control procedures ensured that every enhanced tank met specifications that had been validated through extensive testing. Dr. Richard Chen, whose metallurgical innovations had made enhanced armor composition possible, received reports from combat zones that confirmed his theoretical calculations. "The performance data from Normandy matched our laboratory projections almost exactly," he noted in a classified report to Washington. "The enhanced armor was stopping German projectiles that would have penetrated conventional protection by significant margins."
Their commanders. The knowledge that their tanks could match German armor in direct combat eliminated much of the fear that had characterized earlier engagements. This confidence was reinforced by consistent combat performance. Enhanced Sherman tanks achieved kill ratios against German armor that completely reversed the patterns established in North Africa and Italy. Instead of losing 3 or 4 tanks for every German vehicle destroyed, American armor began achieving favorable exchange rates that leveraged their numerical superiority. The Battle of the Falaise Pocket in August 1944 provided the most comprehensive test of Steel Thunder's effectiveness. American and Canadian forces attempted to encircle retreating German armies, leading to intense armored combat as Wehrmacht units fought desperately to escape the trap. Enhanced Sherman tanks played crucial roles in blocking German escape routes and destroying enemy armor attempting to break through Allied lines. Major General John Wood, commanding the 4th Armored Division, later described the battle as a revelation of American armored capabilities. For the first time in the European War, our tanks were outfighting German armor consistently. The morale boost was enormous, not just for tank crews, but for the entire division. German after-action reports from Falaise revealed growing awareness that American tank capabilities had fundamentally changed. Wehrmacht intelligence officers noted that American tanks were achieving penetrations against German armor that should have been impossible with standard equipment and ammunition. However, German industrial capacity was too strained to respond effectively, even with accurate intelligence. The success at Falaise led to expanded employment of enhanced tanks as American forces advanced across France. The rapid pace of the advance made it impossible to maintain the careful operational security that had characterized earlier phases of the campaign. Tank crews began to understand that their vehicles possessed special capabilities, though the full extent of Steel Thunder remained classified. Lieutenant Colonel Richard Hayes, commanding a tank battalion equipped entirely with enhanced Shermans, noted the change in his crew's attitude as they advanced toward the German border. The men began to realize they had something special. You could see it in how they handled their tanks, how they approached combat. They knew they could take on anything the Germans had. The pursuit across France demonstrated the strategic value of the Steel Thunder deception. German forces had committed to defensive strategies based on assumptions about American tank capabilities that were no longer valid. When American armor proved capable of defeating German defenses that should have been effective, Wehrmacht tactical planning collapsed. The German response included desperate attempts to rush new tank designs into production. The development of the King Tiger tank was accelerated, and experimental designs like the Jagdpanzer were pushed into service before adequate testing. However, these efforts came too late to affect the outcome of the campaign in France. American intelligence monitored German attempts to counter their improved tank capabilities through signals intercepts and prisoner interrogations. The information revealed German confusion about the extent and nature of American improvements, confirming that the deception aspects of Steel Thunder had been successful. General Dwight Eisenhower, who had been briefed on Steel Thunder shortly before D-Day, observed its effects during his visits to frontline units. "The transformation in our armored forces' effectiveness has been remarkable," he noted in a private communication to General Marshall. "What began as a significant disadvantage has become a decisive advantage."
American armor. This shift was documented through prisoner interrogations and captured German communications. Hauptmann Friedrich Müller, commanding a company of Panzer IVs captured near Nancy, described the psychological impact of facing improved American tanks. "We had been told our armor was superior, that American tanks were inferior machines. When we discovered this was no longer true, it shattered our confidence in everything we had been taught." The intelligence value of Steel Thunder also became apparent as the campaign progressed. German forces revealed their defensive preparations and tactical intentions through their responses to American armored attacks. This information proved invaluable for planning subsequent operations and predicting German strategic decisions. The approach of winter and the stabilization of front lines in October 1944 provided an opportunity to assess Steel Thunder's overall effectiveness. Combat performance statistics showed that enhanced Sherman tanks had achieved kill ratios against German armor that exceeded the most optimistic pre-war projections. More importantly, the psychological impact had fundamentally altered the balance of armored warfare. Major Elena Vasquez, now promoted to lieutenant colonel and assigned to evaluate the program's long-term implications, compiled comprehensive reports on Steel Thunder's combat performance. Her analysis confirmed that the program had not only met its technical objectives, but had created strategic advantages that extended far beyond immediate battlefield effectiveness. The deception aspects of Steel Thunder continued to pay dividends, even as the program's existence became more widely known within American forces. German intelligence remained uncertain about the extent of American improvements, preventing effective countermeasures and maintaining uncertainty in Wehrmacht tactical planning. The preparation for what would become the Battle of the Bulge provided the ultimate test of Steel Thunder's psychological impact.
German forces planned their offensive based on assumptions about American armored capabilities that were no longer accurate. The shock of encountering enhanced Sherman tanks in defensive positions contributed significantly to the offensive's failure. During the initial phases of the German attack in December 1944, enhanced Sherman tanks played crucial roles in slowing German advances and buying time for American reinforcements to arrive. Their ability to engage German armor effectively at all ranges prevented the breakthrough that German planners had counted on to reach their objectives. Sergeant First Class Anthony Romano, commanding an enhanced Sherman during the defense of Bastogne, described the psychological impact on German crews. You could see them hesitate when they realized our tanks could hurt them just as badly as theirs could hurt us. That hesitation was often enough to give us the first shot advantage. The failure of the Ardennes offensive marked the effective end of German armored capabilities on the Western Front. While German forces continued to resist fiercely, their ability to conduct large-scale armored operations was broken by the combination of material losses and the realization that their technological advantages had been neutralized. The final phases of the European War saw enhanced Sherman tanks spearheading the advance into Germany itself.
Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.